Your phone buzzes. Your heart jumps before your hand even moves. Nothing happened. No danger. Just a notification. But for 1/10 of a second, your body prepared to run. That reaction is not a glitch. It is ancient machinery doing exactly what it was built to do. And the real answer for why it fires so easily is far stranger than most people realize. You were not built for comfort. You were built to survive a world that wanted to eat you. 200,000 years ago, your ancestors slept in small groups on open ground or in shallow caves. The dark outside the firelight was not empty. It held leopards, hyenas, and other bands of humans who might not be friendly. Every rustle in the grass carried a question. Is this food, or is this something that eats me? The humans who answered that question quickly stayed alive. The ones who paused to weigh the evidence carefully, who waited for more information before reacting, often did not get a second chance. Nature does not reward accuracy, it rewards speed. So your brain evolved a shortcut. Deep inside your skull sits a small almond-shaped structure called the amygdala. Its job is not to think. Its job is to react. Neuroscientist Joseph Ledoux, who has spent decades mapping fear circuits in the brain, discovered that sensory information can reach the amygdala through two separate paths. One path runs through the thinking parts of your brain, slow and careful. The other skips straight from your eyes and ears to the amygdala itself, bypassing conscious thought entirely. That second path is why you flinch at a shadow before you know what it is. Your body decides you are in danger before your mind has even finished forming the thought. This made sense when the threats were physical. A snake in the grass. A stranger at the tree line. Fast physical danger met with a fast physical response. But here is the strange part. Your amygdala cannot tell the difference between a predator and a Slack message. It only knows sudden. It only knows unexpected. It only knows unresolved. Think about the last time you felt your stomach drop. Was it a real threat? Or was it an email from your boss with the subject line, "Can we talk?" Nothing in that sentence describes danger. But your ancient alarm system does not read subject lines. It reads uncertainty, and uncertainty is close enough to danger for your body to treat it the same way. Why would evolution build a system this jumpy? Wouldn't it be more efficient to react only to real threats? The answer comes from a concept researcher Randolph Nesse calls the smoke detector principle. A smoke detector that only goes off during an actual fire seems efficient, but a smoke detector tune that precisely will sometimes fail to catch a fire early enough, and that single failure can be fatal. So we build smoke detectors that go off too often. Burnt toast, steam from a shower, dozens of false alarms for every real fire. The cost of a false alarm is a little annoyance. The cost of a missed real threat is death. Your brain runs on the same math. 1,000 false alarms cost you a racing heart and a bad night's sleep. One missed predator costs you your life. So natural selection built you a brain that would rather be wrong 1,000 times than right once too late. That trade-off kept your ancestors alive on the savannah. But you are not on the savannah anymore. You live in a world engineered to trigger that exact alarm system over and over all day long. News alerts, red notification bubbles, unread messages sitting in bold text. None of them are predators. All of them get treated like predators because your threat detector has not been updated in 200,000 years. There is a second piece to this puzzle, and it comes from psychologists Daniel Kahneman and Amos Tversky. Working together in the 1970s, they demonstrated something that reshaped how scientists understand the human mind. Losses feel far more powerful than equivalent gains. Losing $20 hurts more than finding $20 feels good. They called this loss aversion, and it runs through nearly every decision you make. Why would your brain be wired this way? Picture two early humans. One is highly motivated by potential rewards. The other is highly motivated by avoiding potential losses. The reward seeker takes risks chasing a bigger meal, a better mate, a shinier opportunity. The loss avoider stays cautious, protects what they already have, and survives the risks the reward seeker did not. Over enough generations, loss avoidance wins. Your brain inherited that wiring. It is not being dramatic when a small piece of criticism outweighs 10 pieces of praise in your memory. It is running an ancient program that once kept your ancestors from losing the one thing that mattered most which was staying alive one more day. Put these two systems together. A fear response that fires on uncertainty rather than actual danger, and a brain that weighs potential loss far more heavily than potential gain. Now look at your phone again. Every app on that screen was designed by people who understand this wiring extremely well. An unread number in a red circle is not neutral information. It is a small, unresolved loss, sitting there, unfinished. Your ancient brain treats it the way it once treated a rustle in the grass. Something is unresolved. Something might be bad. Check it. Check it now. You open the app. The alarm quiets. For a moment, you feel relief. Then 5 minutes later, a new number appears, and the entire cycle starts again. This is not a personal failing. You did not choose to have an amygdala that cannot distinguish a wasp from a Wi-Fi outage. You inherited a nervous system built for a world with lions in it, and you are using that system to survive a world with group chats in it instead. Robert Sapolsky, a neuroscientist who has spent much of his career studying stress in primates, points out something important about this mismatch. In the wild, a zebra's stress response is short and sharp. A lion appears. The zebra's body floods with alarm chemicals. The zebra runs, and either the danger passes or it does not. Either way, the stress ends within minutes. Sapolsky's research shows that humans are different. We can trigger that same biological alarm just by thinking about a problem. We can lie awake at midnight, replaying an argument that already happened, and our body responds as if the lion is still standing there. Zebras do not lie awake worrying about tomorrow's lion. You do. Your imagination, one of the most powerful tools your species ever developed, can also trap you in a stress response with no predator in sight and no way to outrun it. So what do you do with a brain that was built for danger you can no longer see? You cannot delete the amygdala. You cannot switch off 200,000 years of survival programming with a single decision. But you can learn to recognize the alarm for what it actually is. Not a verdict on reality. Just a fast, ancient guess, optimized for speed over accuracy, doing its best with incomplete information in a world it was never designed for. The next time your chest tightens over an email, or your stomach drops at a notification, or a small piece of feedback replays in your head for hours, you are not weak, and you are not broken. You are simply carrying a nervous system built on a savanna, trying to survive in a world made of screens. That gap between the world your body expects and the world you actually live in is not going away. But understanding it changes something. The alarm still fires. It will always fire. Yet now, when it does, you can ask yourself a question your ancestors never had time to ask. Is this actually a predator? Or is it just uncertainty, dressed up as danger, the way it has always been? Your phone buzzes again. Your heart jumps, just like before. But this time, you know exactly why.